Hi, welcome back to SPE Live. Great to see you all today. We have a great show lined up for you all today. But first, a big thank you to our sponsor, SPE Foundation, whose sponsorship makes SPE Live partly possible. So thank you, SPE Foundation. Today, on today's show, we're going to be taking a look at data science, AI, and me. So the role of data science, artificial intelligence, machine learning in upstream oil and gas. It follows on from last week's SPE Live, last Monday, AI in energy, resiliency, and efficiency gains. And that SPE Live looked at how AI is being deployed in the energy industry to help create greater resiliency and operational efficiency. So we'll be picking up some of the themes from that last week's SPE Live. So today's SPE Live, data science, AI, and me, we want to take a deeper look at AI, machine learning, big oil, and big tech. And in addition to your questions, so it's very important that we get your questions, so please ask our panel of experts as we get going. But in addition to your questions, we'll be asking three big questions of ourselves. Is oil and gas moving fast enough in digital transformation? Many people, many commentators say, no, we need to go faster. So we'll be asking that question. Second question we'll be asking ourselves is, do I have the right tools? And that includes reskilling and upskilling. So that's all you folks out there listening to this show. And the final question we'll be asking ourselves is, am I asking the right questions? So are you asking the right questions about the data that you have to get the results that you want? So we'll be taking a good look at all those three questions. So helping me answer those questions today, I'm joined by a really fantastic expert group of guests. So, first of all, Maria Angela Capello. She is the Executive Advisor for Deputy CEO of North Kuwait, the Kuwait Oil Company. Nearly 11 years at KOC, she provides executive consultancy support to the North Kuwait Directorate, steering several key initiatives for that asset for KOC. So, standardization of reservoir management, best practices across KOC, alignment and integration of talent development for KOC employees, and also the KOC Shell technical agreement. And she's also coordinator and advisor for the K Company's Professional Women Network. Earlier leadership roles for Maria were at Halliburton Landmark and PD Vesa. She also chairs SPE's Business Management and Leadership Committee. She is a distinguished lecturer at the SEG. Also joining us today is Andrea Schmidt. She is Data Science and AI Solutions Architect at Spark Cognition. She's had early roles as Data Science Consultant at ELE.ai, and in those roles she's developed client solutions, presented proof of concept use cases for clients interested in adopting data-driven technology and processes into their organization. Also, she has a lot of experience with data science and logistics, and she is an AWS Certified Machine Learning and Solutions Architect Associate. Also on the sofa today, John Hudson. According to his LinkedIn profile, he is adaptable, curious, and human, which is really nice. He is global leader for Shell's subsurface workflows. He's had well over 17 years in Shell. Previous roles include software development team lead, Shell Global Solution real-time operations portfolio coordinator, and team leader. So extremely experienced there in data science. And finally, Bill Abriel. Spent the last 5 years as a geophysical consultant at Arinda Geophysical, and prior to that, 37 years at Chevron as a geophysical advisor. He has a very short LinkedIn resume, but has extremely extensive experience in geophysics and data science. He also chairs the SEG, AAPG, and SPE Energy and Data Conference, so we'll be talking more about that later on in the program. So, big welcome to all my guests. Great to see you all. Thank you for joining us.
Morning.
So we are going to kick off with the first question. I'm going to throw this one to you, John, first of all, and then maybe Andrea, you can chip in, and then we'll just move around the table. So is oil and gas moving fast enough in the digital transformation?
Yeah, of course, the answer is probably never fast enough. I think in some areas we are moving together pretty quickly, and I think in particular we know how to partner together. So we're seeing in drilling, for example, really nice paced developments in AI, in geosteering, for example. I think the challenge has been for more subsurface oriented areas, so we've tended to be closer and wanted to develop those things ourselves. So the challenge is really how do we develop more of an open, um, you know, capability of partnering together to take advantage of work that's going on in different organizations.
All right, thanks, John. Andrea, you come from the outside of oil and gas. You have a lot of experience from outside our industry. Tell us, what do you think? Are we going fast enough?
Well, just from my experience working with Spark Cognition, I would say oil and gas is a large bulk of our business. So there's a lot of interest, and we're talking to a lot of companies and throughout the industry, all from downstream and upstream. So I would say, while you may feel like oil and gas is not moving fast enough, I think everyone is in the same boat. Most people are thinking they're not moving fast enough. There's a ton of data out there, not just talking about, oil and gas, but other industries, manufacturing, in the automotive space, and everyone is trying to catch up, I would say. But really, the people that are at the forefront are the big major technology companies. Everyone else is in the same boat. They're still trying to experiment and understand what value they can get out of their data. So we just on Monday, we just released our press release. We've been working with BP for a large part of 2 years now. And we have now models that are live in production, AI models in large scale deployments, really the first of its kind. So I would say that you may feel like it's not moving fast enough, but I wouldn't feel too behind.
Oh, thank you. That's really cool and really great to hear the news about BP. So maybe we can talk a little bit more about that later. Maria, let's switch to you. You have a lot of experience from KOC in terms of applying best standards across and operational practices across the company. Can you tell us a bit more about your perspective on this?
Well, I would say that as per the publications and my own direct hands-on on this matter, you would be surprised of how far the Middle East has already gone into digitizing what is, for example, in the realm of digital oil fields and drilling in particular, and in sensors. And globally, I would say that the trend is very advanced. The thing is that perhaps one of the standards, standards to acquire, share, and then move information around. That's why I consider that the experiments done really already like more about 10 years in Kelsey and in Aramco and in the region, ADNOC and others, onshore and offshore, will shed a light about what are, for example, the opportunities which are there and the blockers, in particular standards and cost. So I would say that maybe we can do better. I would like to highlight that it was just compiling some data about the Generation Z, the newcomers into our industry, and only 36% of them believe oil and gas is the industry of the future. I think careful and uplift the image that as an industry we have collectively, basing our assumptions and our best profile by sharing what are we doing with artificial intelligence, machine learning, and all this new trend of digital transformation in oil and gas, because it is going on and we have a lot going on in that area. The thing is that perhaps more the advances and the progress that we have had. So more later. Thank you.
Thanks, Maria. So, yeah, new trends. Maybe we can do better is what I heard. Bill, what do you think? Maybe we can do better?
Oh, good. Niels, how am I doing? Am I
Yeah,
coming
you're great.
across okay? Oh, thank you. Uh, well, one of the things that I think that we can make an observation about is that when outside consultants are looking at our industry as opposed to other industries, one of the things that they make an observation about is that they feel that the supply chain for the oil and gas industry is particularly inefficient. That comes from a combination of lots of different factors, some of which are historical and competitive, but some of those are because of the complications, right? It's not like we're trying to sell one product or do one thing. The oil industry has got probably the largest number of different data types anywhere that anyone can think of. So if that's true, right, and the supply chain needs some efficiency, uh, we're introducing even more data types in the subsurface, certainly, right? DAS types, monitoring issues, all sorts of different data types. We don't actually even have cooperative arrangements for data exchange formats for those data types. That's actually a big problem, right? So the I think the way forward is going to be cooperatives, and the cooperative practices are going to be things that allow us the opportunity to be able to coordinate legally the things that we can coordinate internationally across professions, which is why it's really important we talk a little bit about the interaction between geophysics, geology, and engineering. And I think that the point is, of course, that that's a subsurface focused practice. A lot of things are happening in there that actually are very inefficient in terms of workflows and data management. So I'm proud to say that there are some initiatives going forward, and there's three that I can talk about that I'm very familiar with. One of which is SEG has a research arm, and that particular research arm is looking at the issues of benchmarks and data formats, right? In addition to that, there's an industry initiative called OSDU, Open Subsurface Data Universe, and that's also focused toward an exchange process of not just formats, but also the ability to interplug and interuse data systems. Those are really big. I think they're going to make big progress. It's going to help a lot, and it's going to make the whole data process a lot more efficient. So energy and data is also another one of those cooperatives. SPE, APG, and SEG are cooperating in this energy and data experience, and I think that that's another paradigm of cooperation that'll push us forward.
Niles, you're on mute.
I am indeed on mute, so there we go. Bill, thank you. You picked up on some really important points there about data formats and the complexity and maybe the variability of the supply chain in oil and gas. So obviously, and you touched upon cooperation, the importance of cooperation. So let's maybe talk a little bit about big tech and big oil and the cooperations we need around that and what that can do. There's a very good comment coming in from Pim Vood. What you see as catalysts or enablers that accelerate the transformation. So, that is that cooperation, right, in part, but also the impetus about the value of the data that we need to analyze. So let's talk a little bit about that cooperation aspect, big tech, big oil. Where does that lead us? Who wants to kick off?
Niles, maybe I could just jump in there. I mean, I really like the thought of a supply chain. If you think about what we've seen in supply chain management over the last 10 or 20 years, it's radically different than where we were 20 years ago, right? You look at offshore supply chains, we've hugely optimized those and brought a huge amount of cost savings there. But with subsurface data processes that Bill was talking about, actually a lot of that is still pretty difficult. If we move from geophysics to geology and bring in petrophysics and all the way to reservoir engineering and production forecasting, for example, there aren't very easy ways to move data through there, and often we lose the richness of analysis that we pay for as we move from one to another. So I think that these cooperative initiatives that Bill was talking about could really help us if we get behind them and make them work.
Yeah, thank you.
I
Maria,
would like to say
sure.
something.
Please.
we can see there are some collaborative efforts already ongoing. And when BP announces that they want to move all their geosciences and subsurface, including reservoir engineering, towards cloud computing, and for example, in late 2019, early 2020, Microsoft signed a big cooperation agreement with Baker Hughes for the same via Azure cloud computing. So you can see clear signs that the industry is moving towards a collaboration with the supplier, specifically for that formats, sharing and the availability of data to all, especially for the international users that have operations, and they may want to gain from the best practices from one region to the other very quickly and very rapidly. So this is something that we need to pay attention. I particularly like one of the experiences recently in the North Sea. There is one, offshore field, which is the Johannes Sverdrup, as a politician, But the thing is that Equinor, with that, only in 2 years, they accelerated from the blueprints to the building of the platform and all, and they have conceptualized the development of that particular oil field offshore with a digital twin. So they use the whole, chain of planning and construction. They use the digital twin, they call it ECHO. And with ECHO, they were able to not only plan, but monitor, extrapolating into the future what were the needs and how to expedite the different phases. And it's a wonderful example, and they use it as their digital flagship project. So there are clear signs in the industry. We are moving fast in the good direction.
Yeah, thank you. Thank you for that. So yeah, there are clear signs, as you say. So I'm wondering, maybe Andrea, you can pick this up as sort of, logistics and supply chain. That's something you can feel and touch and see, but the subsurface is something that we can't see directly or feel or touch directly. So is that a big complication, do you think, in sort of how we utilize tools for data science?
I would say it's a challenge from a validation standpoint. But in data science, there are methodologies that we have where we allow the data to speak for itself. Because in many cases, there's a subset of machine learning where you need to have a target. You need to know what you're looking for in order to train. But we have tools and methodologies available to us where we can adapt our strategy, our data strategy for the data that we're working with. So for example, if you're working in subsurface data and you can't inspect or look at what is some sort of a anomalous event, or you don't have that specific label, it doesn't mean that you can't get insight and value out of that data. You just have to kind of change the way that you formulate the problem, which from the data science perspective is often one of the most challenging aspects of building models and implementing AI is that communication between this is our data from a business perspective or from an operations perspective, what do you want to achieve out of it, versus what are the tools and methodologies that we have available. So often getting those all in alignment can be probably the most challenging aspect in doing some of these projects. But while it's challenging, it's not impossible. The thing about data science is we let the data speak for itself. We don't necessarily have to know what's going on. It's always good if we do. We prefer to have some sort of an idea, hypothesis of what we're looking for, but there are ways to deal with it. And it's currently an area of exploration that we're doing at Spark Cognition, is looking at subsurface drilling data and evaluating how do we pinpoint anomalies, how do we tie anomalies back to specific events that we're looking at, which takes a good deal of knowledge and collaboration. Going back to the collaboration theme, collaboration between your data science team actually conducting the modeling And then just from I would say from a standpoint of the subject matter expert. So who is really understands the data, how it's originating, and what to look for. And the collaboration between the two and the communication that you get between the two is really how you accelerate. Because there was a question, how do you kind of accelerate transformation? I mean, the key aspect, in my opinion, is communication.
Oh, superb, Andrea. And you picked up some really important points there, how we formulate the problem and then hypothesizing what we're trying to look at. So yeah, maybe John, you can take that up. Is sort of do we understand the problem to be solved? How do we pose that problem so we can actually get the best value out of our data?
Yeah, I think that goes back to some of the points that Andrew was making about collaboration and how do we do that. I think there are some really successful models out there. When we don't know what we're looking for, sometimes it's best to have a very collaborative culture there to embed people from different companies, maybe from an operator, maybe from a service provider that really has a particular technology expertise, and have joint ventures over several years to develop something. But I think increasingly what we'd like to see is more of an open source model there, where we can be influential customers that are able to specify very clearly what's needed, and then allow the market to respond to that. So I think back a few years ago when Microsoft vended the .NET code into open source, and the open source community was so grateful for that. It was just a very short amount of time before they had a lot of the code that was similar to that on the Linux side. So the thing that we'd like to see there is more of a development of an ecosystem where customers could specify more clearly what was needed, and commercial models that would allow that collaboration to move more quickly.
Excellent points, John, there about the open source model. So I'm going to come back to that in a minute, maybe. Bill, you've bathed in data all your life as a geophysics advisor, because I mean, it's just tons of data in geophysics. And there came a good comment from the audience from W.K. Rucker about humans don't understand the complexity of data. So, geophysics data is complex. What's your opinion here about sort of posing that problem?
I want to make a comment about that, Niels. I appreciate that geophysics data can be complex, but one of the advantages that I've had is to work through a number of different projects. And I made a special note about my anxiety on a project that I was working on because it had so many different data types, none of which were geophysical, but they were all engaged in 3 or 4 different formats. So just imagine we're trying to work through this project, and we have feet meters, pounds per square inch, atmospheres, darcies, pounds per gallon, barrels, acre feet, metric tons, British thermal units, and Roman numeral million cubic feet. Those are not even geophysical, Niels. Those are oil field characteristics of a particular project. We had to move back and forth between all of those different conversions. And by the way, sometimes they get screwed up. Is just an incredible thought, right? So the argument for standardization practices is pretty strong, right? I think we should do that, number one. Secondly, I do want to see if I can't express myself as being positive about our subsurface characteristics, like we heard Maria Angela talk about the digital twin of the facilities, which is a natural thought. The way to express that about digital twin for the subsurface is that we've been doing that for a very long time. Think reservoir engineering, right? Reservoir simulation practices. We build a reservoir engineering model. That's our digital twin, right? Our digital twin needs work. It needs updating. It needs help. It needs effectiveness. And primarily, that's the way we work toward that. The rest of the subsurface that you have to drill through also needs a digital twin, and the geophysicists have to know what it is, and the drillers have to know what it is. So the whole concept here of model-based practices and physics-based issues becomes linked in with our data practices. Listening to the data and saying, the data told me to do this. It's a little easier when you can say, and that makes sense because we think we understand something about the physics that's going on, and here's how we manage our digital twin to bring that together. That's going to become more effective and more efficient as time goes on. GPUs help us with that. But I think that the whole question of technology development in our industry is the issue. Technology development is not going to happen until we have the standards and formats, recognizing that we're operating a digital twin, and asking for an open source technology full cycle chain practice. There is an enormous amount of energy and opportunity for people to be able to help as long as we can get the well posed problems out in front of the open source community. I'm absolutely convinced that that's going to be the workflow of the future, and that we'll be able to bind these organizations together, the suppliers and the providers and the operators, in an open source environment where we're all sharing in a technology development practices, a rising tide that lifts all boats.
Maria, you wanted to add to that, I think. Please.
Well, as soon as somebody says open source, there I am, because I consider that is one of the pivotal differences between the international oil and gas companies and perhaps the national oil and gas companies. There is like a dichotomy, a different approach, a very different approach to that. With international oil companies understanding the value of sharing data sets. And we have the case of the, Equinor sharing their North Sea data set that can be used for modeling, for experimenting in the digital world with that. And instead, of course, the national oil companies in Latin America, in the Middle East, and elsewhere, taking, a hold on their data sets as an asset, because that positions them in many ways in regards to their standing. For example, could be OPEC, could be other multilateral organizations where reserves and details on the subsurface are so crucial. But that reminds me also that Bill was talking about collaboration and sectors, and it's not only oil and gas and our vendors. It's beyond that. I was thinking the other day that one of the key changes that machine learning brought into the operations was, for example, the kind of alarms that you can set for the maintenance. Instead of going to routine maintenance with, setting shutdowns for the whole plant, or if that was downstream, or for the whole gathering center in upstream, now you can do that with machine learning and do that at the right time. So what is the problem? That many times the insurance and the certification of your operation and equipment depends on these shutdowns. So even the insurance companies and the other, partners, stakeholders that we have in our business have to upgrade their policies, procedures, so that the oil and gas and all together we can move and embrace, digital transformation, including machine learning and artificial intelligence. It's just a comment, but I think it gives a flavor of the colorful, facets that this kind of issue implies in oil and gas. Thank you.
Yeah,
Andrea. Yeah, John, please. Yeah, and then Andrea.
I was just going to jump in. I think Maria's right that of course the international oil companies have been close to hold their data, but I think that's changing as well. So certainly we all want to do our jobs well, and we're also trying to find ways to be more efficient at that. So we're, I can tell you within Shell, we're actively looking out in all sorts of places for collaborators and partners on innovation, particularly in the subsurface. So there's some very good work that's going on in both traditional oil and gas companies and also beyond that. So I think you're going to find that, particularly with the business environment of this year and the move to be able to do work more remotely and to be more cost effective, that there's going to be a lot of open opportunities for partnering, for collaboration, for proving value. I think that the challenging thing is going to be that the business models have to be even more robust. and maybe there's a little bit more of a short-term focus, but the kind of innovation that we're seeing this year, particularly around remote working and being able to do things in more digital ways through that, we're seeing significant changes already this year.
Yeah, thanks, John. Andrea, do you want to pick up a little bit on the sort of the physics-based models versus the AI?
Yeah, I've heard. So you've been referencing physics-based models and also having digital twins, which is wonderful from getting organized from a data perspective. And what I would like to kind of bring up is that there is a clear difference between AI-based models and physics-based models. And for those in the audience that may not be familiar with how an AI model versus a digital twin is different, you can kind of think of your car, your vehicle. When you buy a brand new car, it has a certain operating state. And you could take a snapshot of that car when you buy it, or a piece of equipment brand new, and say, this is its digital twin. But the reality is that over time, as you drive the car, operations may change a little bit, but they're not abnormal, right? It's just maybe deviating or evolving or somehow changing, but it's still considered a normal operational state. A physics-based model will pick up on those changes and alerting, whereas an AI-based model is going to be able to learn how the equipment is changing, whether that is normal or not normal, therefore making the maintenance of the digital twin, because the digital twin needs to be maintained, makes that obsolete, right? In an AI model, you're not necessarily focusing so much on maintaining it.
Oh, that's fantastic, Andrea, to hear what you were saying there about the differences between the models. And that goes back to what Bill was saying about the physics-based and the model-based practices and the data-based practices, and the need for collaboration, which everybody's echoed, the need for collaboration between big tech and oil and gas. So, there's a lot of talk about open source community, and I think that strikes fear in many people in terms of, I can't share my data because it's, protected, it has a value to me. So maybe we need to make a distinction between what we mean by open source community and sharing data freely, because the two are distinct, essentially. And Maria, you also touched a really important point about that transition from periodic maintenance to preemptive maintenance using machine learning and AI, and that's a really good example of oil and gas using digital technology. I wonder, when we talk about collaboration, and a lot of questions we're getting in or from earlier is about, what skills do I need as an engineer in this new transition? How do I upskill? How much do I need to know, and when do I need to ask somebody else to help me? Maybe, John, we'll start with you from the Shell perspective on that.
Yeah, so it's something that's changing really rapidly, I think, right now. So I think even just 3 or 4 years ago, we were expecting that a lot of subsurface professionals would be learning Python or R or some, and of course what we're finding now is that the tools that are a lot easier to use sometimes have the best approaches embedded in them. So I think I was actually having a conversation with Felipe Hervé from Spark Cognition. So I don't know if Andrew wants to pick up on this, but the kind of packaged solutions that are kind of out of the box, scalable, supportable, and help you understand kind of how the model is behaving in the current environment best are often ones that you don't have to do a lot of programming, a lot of self-development. So Felipe's example was that you don't build a computer specific to a problem. You buy a general computer, and then you may have some special software for doing the thing that you're trying to do. And I think we're getting to that point in these AI and ML technologies as well, where compared with just 3 years ago, it's really about bringing your domain experience. And of course, it's not to say there won't be a subset of problems that are difficult and challenging that will require an AI expert to solve. But I think we're going to see more and more advanced approaches that make that much more accessible to people that have more domain experience.
And then just to add to that, I would agree that domain expertise is usually going, over time, is going to be more important and more critical than necessarily, having a PhD in data science. We're starting to, with open source, with new training and education and tools, we're starting to lower the bar for what it means to be able to do data science work. So what we like to do is we like to enable more people to come in and do data science without having to do the really, lots of education, heavy math and statistics. While it's very helpful, and you do have to know and understand like the concepts of how machine learning models learn, because that will always be a really critical communication aspect. Knowing the actual heavy machine learning, I think, is going to be taken over by tools that are specific to industries, as you had mentioned.
Oh yeah, fantastic point there, Andrea. Again, the difference between the understanding the fundamentals and the fundamental concepts. Bill, please.
Yeah, no, I think it's a really interesting question. One of the things that I've done is I've been a business consultant for a startup company that works on downhole submersible pumps for production, and they're data science oriented. And the question is how it is that we're going to develop the right AI model so that we can predict failure. Using AI products, pick up the number of right sensors, sensing a number of different things about the shake rates and pressure rates, and the question about whether or not that pump is going to fail in the future or not. So the right way to understand that is through a data science perspective, right? And the people that are working on this are doing an extremely good job. They pulled together the model. They've got the data information gathered at the edge, right? So they can broadcast it as a dashboard. And sure enough, there you are. And and when the light goes yellow, right, it says, "Uh-oh, pay attention to pump number such and such and well number such and such." Go out there and check that. If you know a priori, right, that this is going to take place, you've got time to order the machinery. You don't have to check every pump all the time. It's a very considerable savings. It's about a 30% production increase to be able to do that. So that's a data science oriented practice that really comes to play subsurface, does exactly what AI is supposed to do, which is analyze the data and get you to wake up and pay attention. That way you can intervene and say, now let's get into the physics-based problem of actually replacing that pump, right, and make that happen. I think that's a really powerful way of looking at the merging of activities and one of the elements of what AI can do. So what I'd like to do would be to see if I could change that conversation only just a little bit toward the logical education of AI activities and how they can actually help things out is something that is not commonly understood through a lot of the industry in oil and gas. And because that's true, I think that there's a real need for awareness and training. And I use the word training from the viewpoint of enlightenment and knowledge, right? What is AI? How does it work, right? Where are we trying to go with that? I think it's important that we have an opportunity to be able to provide the right sort of, quote, training, if you will, right? In a way that's easy, effective, efficient, with good examples. I think that's important for being able to make progress. And I think that SPE, AAPG, and SCG are in a real good position to be able to build and provide that.
Oh, thank you, Bill. Thank you for that. Maria, do you want to pick up on Bill's comments around sort of the examples of AI being used and sort of to help operational efficiency, maybe in terms of some of the things that you've seen in terms of offshore developments?
Well, I consider that one of the beauties of our conference of energy in data is to share, the successful cases of artificial intelligence and machine learning applications. Because in the conference we will have, first of all, the three societies, right? The SPE, the APG, and SCG. But also we'll make an effort to have upstream and downstream. Why I am mentioning this? Because I think that for training, one of the, successful cases I have seen was to see also the virtual immersion that, for example, Honeywell, not to make any advertising, but I saw that recently, have applied to certify operators of refineries. So you have this virtual immersion, and they manipulate the knobs and valves of control panels for refinery specific panels. And in this way, they avoid accidents, they increment the HSE standards, and they are able to train more people in their home countries or before they send them offshore, for example, to the refinery models that are in the platform, for example. Another example is you may want to think about the training in large and massive scale, which is done in the Middle East by Abriel before sending the people offshore to their facilities. It's also using virtual environments on land with their offices, and after they are certified, they then take it to the option. I have seen from the chat that there are some questions in relation that how come the platform in offshore we don't have opportunity to have a full system, for using data analytics, and well, things are changing. And for example, Equinor is now sending every single worker to the platform with a mini tab, like a mini
Like an
tab to go.
iPad. Yeah.
Yes, mini iPad to go with them, each one of them. Why? Because with that they connect real time to the office and they have access to the data sets.
Yeah.
So I think that after COVID especially, we are seeing an evolution. Finally, I would like to highlight that in academia, from the academia, petroleum engineering and geosciences is also quickly migrating into what we want to call human-based training. I consider that training for data analytics and machine learning is better when you don't need to be instructed about how to use it. It should be intuitive, it should be human-based. And just as recently in your mobile, they changed just, I think, 2 days ago in the WhatsApp, you cannot anymore attach photos as you used to do because they launched these photo groups to make video, etc. It's very intuitive and you can move around because it's human-based. So you realize how to do it. I know you don't need specifically training, and this is why, for example, companies like Equinor and BP are more and more stepping up into providing each individual employee with iPads necessary to remote, so that they are portable and they can have access to it.
Thank you, Maria. You bring up some really good points there about sort of accessibility of data and the training. Again, touching on that training. And that goes back to that sharing or meeting of domain experience. So the subsurface domain experience versus the data science domain experience. And John, you picked up earlier about it was actually a really good question from Jeremy Ross earlier about how the current economic climate is impacting sort of data science and machine learning initiatives. And you mentioned remote working, and it's giving us a different perspective and a different impetus to work together. And maybe learning to work differently is going to be an advantage. I wonder if we can sort of just turn a little bit to oil and gas is really good at adapting to new technology. We have a long history of that. So I think, as Andrea said earlier, we are moving at the right pace in terms of digital transformation. something that always comes up with digital transformation is failing fast, and that sort of agility. So we're great at failing fast at learning how to use a mobile phone, for example. We all do that at home and, whatever else. Are we good as an industry at that agility, or do we need to improve that in terms of how we work with big tech to advance our abilities? John, perhaps we'll start with you.
Yeah, maybe I could turn that around a little bit as well and say, what should we as members of the societies want from SPE and from SEG and APG, for example, because that's the kind of the groups that we have around the table here, and how can they help? I think the current climate, of course, is bringing a lot of pressure to change. I think also we would like to have a way that societies can really help us understand what is a competitive subsurface professional look like. What do they know? What are they able to do 3 years from now, 5 years from now, and then how can we take steps to get there, right? So I think learning experiences like this, the roundtable we're having today in SB Live are very, very helpful. They can be introductory to some concepts. We may be able to get into like webinars, for example, and learn about things. We may be able to go to hackathons and get some experience on getting your hands dirty or your feet wet in some of these technology areas. But what we'd really like to do is allow people kind of an ecosystem to come and play, to whether it's failing fast or succeeding quickly. The key thing is to get the experience and the experience at a deep enough level where it's really meaningful to help people to see kind of what their path forward is.
Oh, great comment. Anybody else want to pick up from John there, talking about the experience and being a meaningful learning experience in terms of understanding?
I think only one phrase. I think that we need to increment our appetite for risk. You need to let people try. We need technology.
And I could also add to that data science is really rooted in curiosity. So as long as you're curious and you have the data, it's about exploration. There is the science aspect of it. So be curious, learn new tools. Don't fall in love with any one of them, because it's a rapidly evolving industry and technology is rapidly evolving. But I would say the best way is to be curious. And from an industry, oil and gas, if you want to be faster at failing fast and getting more agile, I would say with your technology partners, establish good relationships, good amount of trust. And when you have trust and good relationships with your technology partners, then we do this all the time. We're very fast moving. So I was going to say you can probably use us as a tool, as a mechanism to help you in your company move forward, move fast, experiment, find out what works, what doesn't work, so that you can get to the solution fastest.
Excellent, Andrea. Yeah, that's that issue of trust and being able to work in a sort of collaborative way. Bill, let's turn to a little bit picking up on these ideas of open source ecosystems, being curious, appetite for risk. Talk to us a little bit about the Energy and Data Conference, because we've got the closure for the abstracts coming up next week, right?
Oh, excellent. Yeah, one of the things that we're engaged in between the institutions of SPE, AAPG, and SEG is to try to build an experience so that folks get the opportunity to understand what we're trying to accomplish here in energy and data. The purpose of energy and data is to build a community of like-minded or interested people to try to advance the science and make the industry move forward. So there are a number of different vehicles we can use to do that. Some of those are webinars that you may already be aware of. Some of that is like this podcast. There are courses available. There is a conference set for next year in Austin, Texas, and in that we'll have a number of different channels that can come forward. papers that will be presented in tech session, but probably more importantly, the interactivity of being able to work together on specific and real data and identify the interesting projects that folks are working with. Hear from the panelists that are able to debate and discuss the important parts of energy and data practices, and connect people in a way that they can't connect otherwise. So energy and data, if you think of it as a conference, that's interesting, but I really don't see it that way at all. I see energy and data as an ongoing community, and joining that community, the conference is more like a summit that we'll all be get together. But at the same time, I see that community thriving throughout the year, and an opportunity for us to be able to work toward a common way of improving.
Oh, thanks, Bill. Yeah, that's really important message, and I think a really good concept in terms of building a community and sharing that journey. We talked about it earlier, having that whole ability to cooperate, collaborate across those boundaries, and develop that open source culture, that ecosystem. We're close to the top of the hour. The time's gone very quickly. Huge subject to talk about, right? So let me ask you all, give us a quick sort of takeaway. What's your message to the audience now, sort of going forward from this conversation and all the resources that are available and the challenges that we face? So, Maria, we'll start with you and then we'll work our way around Andrea, John, and end up with Bill. So, Maria, please kick us off.
I would like to say that COVID probably taught every one of us we need to be ready. And remote, quick, and access to share resources is pivotal. So don't be afraid, embrace change, and go for it.
Thank you, Maria. Andrea, what's your takeaway, your message?
I would say my main takeaway would be to start thinking differently. I know that you've been, you're used to, as an industry, operating a certain way, things are done a certain way. But in order to change, you have to kind of start changing your mindset. And data science and AI requires a little bit of a mind shift and a mind change about how you manage data, how you manage people, how you want to interact with technology. How do you want the future to look like? Because AI is really, it's new. It's still emerging, so it can really turn into what you want it to turn into.
Awesome. Thank you, Andrea. John.
Yeah, I'd like to pick actually up on a couple of things that Andrea said earlier. One, I really liked the comment of explore a lot of different things. Don't fall in love with a particular thing, so you can kind of get a kind of broad understanding of what's emerging, and also things are moving so quickly that you may not want to kind of dive down in the weeds of any one area. And the second thing she said that I really liked is think about who you are, what you bring to the table, because you don't have to be something that that somebody else is doing. You have a unique set of experiences and depth, and that's going to help. And then the third thing, I just put a plug in for energy and data here again. I think that's a community that's really trying to make sense of both the data aspects of this and the subsurface integration aspects, across the various disciplines. So that's an exciting community, I think, really leading conversations that are there. So welcome others that may be listening in today to kind of get involved there.
Thank you, John. Yeah, that's, again, really important points there. Bill, let's round off with you.
Oh golly, there's a question, and I love this question from Razan Ali. It says, reservoir engineers are already using neural networking, statistics, automation, regression, Monte Carlo simulation. What else can data science bring to the table? And I think the answer is, there's a lot of uncertainty in geology. I mean, if it all worked perfectly, right, we'd all be out of a job if it was easy to predict. So surprisingly, I think it's the heterogeneity of the subsurface, which is why geology and geophysics become so important. The geology is all about the what is, and the geophysics is about can we see it and predict it. That's why you really want geoscientists involved in your prediction and being sure that that digital twin is accurate and predictable, which is where the value comes from. Yeah, no, AI is definitely going to have an impact there. I just want to point out that it's cooperation between those professions that's going to make the difference. I can tell you that energy and data as a concept, right, is the ability to be able to have those discussions between the three professions that operate the subsurface and the massive uncertainties that we face there. Cooperation elements are extremely well shown through this very practice that we're looking at right here. It's a pleasure working with Nils, and it's a pleasure working with Andrea and Maria, John. All I can say is that there's no question that cooperation is going to be our paradigm of the future, and we are very pleased to be able to step forward and lead by example.
Oh, thank you, Bill. Powerful messages from all of you. Thank you. So, I mean, for me, it really resonates with that coming together, collaborating, joining forces on domain experience. Philippe Hervé said earlier, there's going to be a lot of automation of AI and machine learning tools in the future. So we don't need to think about the tools that necessarily or how they work. It's like getting in a car and just driving, right? You don't need to know how the engine works. You just know roughly how it works. But so I think being able to use those tools and then meet in a collaborative environment between the domains is what will actually transition us into the future. And I think that's what oil and gas has always been able to do. So for me, that's really exciting. So huge thank you to all of you. A fantastic conversation today. So thank you, Maria, Andrea, John, Bill. A big thank you to the audience. A big thank you to Asha for doing all the production in the background. Without you, it's not possible at all. And a big thank you to our SPE Foundation sponsors as well for making this possible. So thank you, everybody. So all of you guys, thank you. I look forward to talking to you all again soon. So thank you very much.
Thank you.
Makes sense.
Thank
Thanks,
you.
guys.
Thank you all.
All right. All from us for now. Thank you. Bye.
Bye.